Consider the curve as equation. The tangent to the curve at the point where axis 1 is parallel to the line, find the value OK. We know that if two lines are parallel, they have the same gradient. And since it is given a tangent, and if we know the gradient of this tangent, we can equate gradients and hence get an equation and solve for k. How to find the gradient of a tangent? We know that the gradient of a tangent is equal to the derivative of a function at the point where it is drawn. So gradient of a tangent is equal to derivative of y at point 1, because it is drawn at axis 1. And also gradient of a tangent, since it is parallel to this line and it's a straight line, all the form as usual mx plus c, and gradient is 5e to the power of k. Hence this gradient also is equal to 5 multiplied by e to the power of k, and hence we get an equation. So we can see that we need to find derivative firstly, so let's consider derivative, and since x is here and x is here, we should consider this function as a product of two functions and hence apply a product rule. It is given, this formula is given in a data booklet, and it says that if function is uv, derivative it's u primed v plus u v primed. Hence y derivative of x, it's 2x minus 1 derivative e to the power of kx plus 2x minus 1 e to the power of kx derivative, and it is equal to 2x minus 1 derivative is just 2 plus 2x minus 1 e to the power of kx derivative. We can see that it's this argument is kx, and we know that e to the power of x derivative is e to the power of x. It is given in a data booklet, but it has more complicated argument, hence we should apply a chain rule, and it says that we apply the same rule, keep the same argument, but according to the chain rule it must be multiplied by argument derivative, kx derivative, hence k arises. Or we also know that if a function looks like a function from a data booklet, but it depends not on x, but it's of ax plus b. So e to the power of ax plus b derivative. We use the same formula as in data booklet, so it's e to the power of ax plus b, but a arises. We multiply by a, and here we can see that since it's kx b is 0, kx, so k arises. So anyway, this derivative is equal to k e to the power of kx, and the gradient of a tangent is derivative at the point 1, hence we substitute 1 for x and get 2 e to the power of k plus 2 times 1 minus 1 is just 1, and multiply by k e to the power of k, and hence it's 5 e to the power of k. We use this because it's a gradient of a tangent, and since this tangent is parallel to this line, they have the same gradients. And we can see that we can divide each term by e to the power of k, and hence we can see that k is 3. And that's all for this question.